Hello everyone, welcome to our webinar Automate Infrastructure Deployment with Azure Resource Manager. We're already here and we can start our webinar. Let me introduce myself. I'm Alexey Baltikov, Cloud DevOps Consultant at Akkad Consulting. I work in projects related to monitoring and automation. Also, as a community enthusiast, I speak on conferences, review IT books, and own video series related to Azure Log Analytics on the Microsoft Channel 9. My colleague Alex Andrushenko is Principal DevOps at Akkad Consulting. He is a team lead and architect at SQL Server Management Pack team, which is part of Microsoft SQL Server Tigers team. And Sergey Kiselov, our supercharged DevOps technical brain who can solve any automation-related problem and task. Sergey prepared demonstrations for this webinar and will help us in Q&A section. Let's start with a bit of housekeeping around rules for this webinar. We expect this webinar will take no more than 60 minutes, and we will have some time to answer questions from our attendees. The recording of the webinar and all the slides will be available for you after the webinar. If you have any questions during the webinar, please use the Q&A tab on the left bottom corner in your Skype for Business client. We will try to answer as many questions as possible at the end of the webinar. If you want to learn more about future webinars which we will host and any updates from us, please follow us on Twitter. And now we're ready to start. I have two main parts in this session. In the first part of the session, I will review Azure Resource Manager and what's more important, its templates. This is our baseline to see how this service will help us. And in the second part, we will demonstrate two case studies from real-world projects where my colleagues implemented automated infrastructure as service and platform as service deployments based on Azure Resource Manager templates. After that, we'll have some time for questions and answers. Part 1. Introduction to Azure Resource Manager. Before jumping to Azure Resource Manager templates discussion, or abbreviated we can call it ARM templates, we need to answer two questions. What is Azure Resource Manager? And what are the key ARM elements? At the beginning, I'd like to demonstrate the value of ARM on a simple example of house building. Imagine that a builder Joe needs to dig a pit for house foundation, and just imagine he tries to work with a shovel. How long he will be digging? Is it an effective method? What if this builder will use another tool, an excavator? Its bucket looks like a big operational arm. So now things are much better and faster. Azure Resource Manager is our automation excavator, which helps to deploy and configure resources in Azure faster and easier. With this mindset, let's go further. So the first question, what is Azure Resource Manager? The answer, ARM is a management layer in the middle between actual resources and users' tools. ARM API is used to access to resources through providers. ARM is a single point of management, and it doesn't matter what supported tools are used. They just request ARM API, and the ARM engine does all the marvel behind the scenes. Consider ARM as a clever automation orchestrator which helps manage either single resource or resource grouped together to deliver business application. The next question we need to answer, what are the key ARM elements? Answer, the first element, resource providers. Each resource provider offers separations and resource types for working with the resources that are deployed. Some common resource providers' namespaces are Microsoft.compute to manage virtual machines, Microsoft.storage to manage storage accounts, Microsoft.web to manage web applications. On the current state, there are about 146 providers, at least in my Azure subscription, 115 developed by Microsoft and 31 developed by third parties. By the way, if you want to know how many providers available in your Azure subscription, you can do it very easy by run the PowerShell commandlet get Azure RM resource provider with list available parameter. Second element, resource. Resource is just instance, manageable instance of produced through corresponding resource provider. Some common resources are virtual machines and corresponding resource provider Microsoft.compute, storage accounts, as mentioned earlier, Microsoft.storage, corresponding resource provider, web apps, databases, virtual networks, and so on. There are hundreds of resources available through resource providers. The third element is resource groups. Resource group is a container for Azure resources. The resource group can include all the resources for the particular application or only those resources that you want to manage as a group. For example, for test or lab deployment, you can put all resources to one particular resource group and then delete them, for example. But for example, for multi-tier production application, you can divide it and, for example, web tier to put to one resource group and database tier to another resource group. And manage them separately. One thing we should know, one resource can reside on the one resource group. We can't split resource and put to different resource groups. One resource group. This is the rule. Another rule of the resource groups, to be a unit of management. Resources lifecycle operations like deployment or update are always targeted at resource group level. For example, ARM templates deployment is targeted at a particular resource group, and you will see it in the demonstration. Okay, now we're ready to move on to the ARM templates overview. So, what is an ARM template? It is a JavaScript object notation file, or simply JSON file, that defines one or more resources to deploy to a resource group. It also defines the dependencies between the deployed resources. Think of an ARM template as a detailed construction plan, which mentioned earlier Joe will investigate and use to build the house. Syntax of the ARM templates is declarative. What does it mean? You focus only on the intention. Like, I need a big white house with 2 floors, instead of particular steps and checks during every step. Here's a simple example on the slide image. You can see on the diagram from the right side that only needed resources declared and without any difficult logic. You can see storage account properties, next virtual machine properties, and dependency on storage account, which means that VM will not deploy it until storage account has not been provisioned. And finally, we can see extension resource, which dependent on virtual machine deployment. By the way, the depends on property used here to orchestrate the order of the deployment, and the extension resource type applied to configure the deployed resources. As a result of this example, ARM will deploy storage account and virtual machine as a complete application rather than just a deployed bunch of Azure resources. By the way, right now ARM supports several popular configuration management tools as extensions. Among them are PowerShell desired state configuration, Chef, Puppet agent, and Octopus Tentacle agent. idempotence or idempotent. It's an interesting term which related to ARM templates too. What does it mean? Simply it means when the same template is executed, the result should be the same each time. Only the required changes are applied to the resource. For example, you declared the one VM in one template. You run this template targeted at one particular resource group, and each time when you run this template, you will receive the same virtual machine, the same single virtual machine, not two virtual machines, not three, but the same virtual machine. So ARM templates perfectly fit into the DevOps infrastructure as code practice. Now let's review the template structure. As you can see on the slide, by the way, it is an empty template. On this particular example, there are 6 blocks inside the curly braces. Schema defines the template language file URL. It is a mandatory element. Content version, it is just a version of the template itself. It is a mandatory element, but increment of the version value is not required. Parameters. Its input values, like in scripts, traditional scripts, they are not required, but very useful. Variables. They used to simplify deployment through creation of needed strings and using them in the template body. Again, like in traditional scripts, they are not required, but they are very, very useful. Resources. This block is used to declare the resource types which will be deployed or updated. It is a mandatory element. And finally, outputs. You can put here the results of the deployment. This section is not required, but again, it is very useful when you're working, for example, with nested templates, or then you need to see the results. For example, you deployed the virtual machine and you want to see the public IP address assigned to the virtual machine. There is another element which is not shown here, functions. Basically, function is a user-defined named expression which can be called in the template body. Let's see a simple example from a virtual machine template. This is a minimized example of a Windows virtual machine template. This template contains storage account, virtual network, network interfaces, public IP addresses, and virtual machine resources definitions. And by the way, I highlighted the actual virtual machine resource definition. Let's examine this particular resource. Do you remember we discussed resource providers and resource types? As you can see here, the type property contains value which consists of resource provider name, Microsoft.compute, / and resource type, in this case, virtual machines. Also, you can see that the virtual machine will not be deployed until storage account and network interface are created. You can see it in depends on section. There are other properties related specifically to VM deployment, such as VM size, admin username and password, provisioning image profile, and so on. Okay, now you know what ARM and templates are. One last question might be interesting to us. How to run execution of the template? There are a lot of tools which can be used. Here is a list. Use what is comfortable or applicable in your environment. Some of them we will see in the demonstrations. That's all I wanted to share with you as an introduction. Now it's time for the most interesting part of our webinar, case studies. And now it's your turn, Alex.
Thank you, Alexei. Hello, everyone. Before we move to the demo, I want to highlight project details. As you know, or probably know, besides the Azure DevOps project, historically, our company developed many system center operations manager management packs for our customers, including management packs for on-premise server products and hybrid and cloud solutions. We keep doing that, I mean management pack development, and at the same time now we are leveraging all the power of Azure Cloud for our customers. One of our management packs projects is about building a monitoring for an on-premise server product. I mean, server products that could be deployed on virtual machine, of course. It's obvious that to deliver the quality product, we need testing. And testing needs environment. And this environment should simulate the real-world environments. If you are familiar with SCOM, you know that the minimal deployment configuration consists of Active Directory, SCOM management server, SCOM data warehouse, and operational databases. Take into account that management pack needs to be backward compatible with previous and next versions of SCOM. It should work on any supported operation system. It should work on each supported version and edition of the product, and it should work on localized versions of the product and operation system. As you can see, we have multiple dimensions for our test matrix, and it's near impossible to test all these combinations by hand in a reasonable time. Can you imagine how big is a typical deployment? The typical environment that we use in everyday development consists of approximately 10 virtual machines. The environment for full regression testing could have 50 or more virtual machines. Each virtual machine has its own installation of a server product version and all the prerequisites, so it's not just an empty virtual machine. Could you imagine how much time is required to deploy such environment manually from scratch? How much time does it take to maintain it? Right, the huge amount of time. So now the environment is deployed and we can use it. Why we may need to redeploy it? First of all, we cannot share the same environment with multiple team members, and there is a reason for that. When we developing the management packs and making changes, management pack with changes need to be imported to the SCOM. Guess what will happen if there are two developers working simultaneously and trying to import different versions of the management pack on the same environment? Or even better situation, when there are two people trying to test management pack. There will be a lot of conflicts of settings and management pack versions that makes sharing of the environment not possible at all. It's very bad practice and waste of time. The second reason is that it's really hard to distinguish the real problem in the management pack from the infrastructure problem. You could spend hours and days trying to understand why it's not working, but the reason may be in wrong configuration, expired key or something else. You do not want to spend all your time on environment maintenance and troubleshooting, right? Instead, you want to have a clean environment every time you need to understand the root cause of the issue. The third reason is an ability to quickly simulate customers' environment with a specific version of operation system, SCOM, and product, and management pack to make effective sustained engineering. There are multiple other reasons, but let me add just one more, the classic reason, and it sounds like it works on my environment. We were suffering from all these issues, and to be successful with our development and deliver quality management packs, of course we built deployment automation. 7 years back, we did it in a way as everybody did at that time. We bought a lot of physical servers, storage, and built our own private cloud based on Hyper-V and Virtual Machine Manager. With the release of Virtual Machine Manager 2012, we developed our deployment automation using Virtual Machine Manager service templates. Look at what a humongous service template we ended up with. It could do anything we wanted, deploy any version of SCOM with any version of server product in any combination. It was a great advantage for our team, and it saved us so much time. Now, we were able to deploy everything that we needed in a reasonable time. Now, every team member could deploy and redeploy his environment with a click of a button. We also built test automation on top of these automatically deployed environments with TFS, and it was almost happiness, and it was almost continuous integration of my dream. I'm saying almost because there was one little problem with deployment automation. Anyone who ever worked with VMM already knows the answer. Right, it was not reliable. And not because of mistakes in a script, but because of VMM. Deployment may fail without reason, just randomly, or after some update on VMM, or because there is a lack of resources in a private cloud, or cleanup in VMM was not successful. As a result, one of our team members dedicated about half of his time to support this solution and just to keep it alive. We were successfully using it in our everyday development for many years, and this solution is still used on smaller projects. But again, after some time, it became harder and harder to support this solution. Deployment was not fast enough and still not reliable enough, especially at scale. We keep adding new servers and resources to our internal cloud, but with a growing number of projects, we approached limits of internal clouds pretty fast. So this is a context for this project, which was a project of migration of deployment automation and test automation to the cloud. So here are the goals of that project. Number one is reliability. It was not enough with our private cloud, and because of that, our test automation was also not reliable enough. We wanted to eliminate manual operations completely. We do not want to spend so much time to support deployment automation. Improve reliability of test automation. We do not want to affect our test because of failing deployments. We want to be able to quickly deploy all the supported platforms and run test automation on them. We want to have faster deployment. We want to have the ability to scale when it's necessary. We want to make it also cost effective and keep it live only when it's really necessary. There were no doubts for us what cloud platform to choose. Because we work with Microsoft technologies and our test automation is natively compatible with Visual Studio Team Services, we've selected Azure and VSTS. And now it's time to see how it all gets implemented. Let me switch to my environment. So here's my project, and this is Visual Studio Team Services portal. Let's go ahead and check what we have in build and release section. I can see build definition, and on a drill down to the build details, I could see build timeline, test results, and all the associated changes. Let's check what is inside the build definition. On edit, I could see build steps. We have 4 steps in total. And the first step is to deploy environment. The second step is to execute all the test automation. Next step is a cleanup. On this step, if all tests passed, the environment will be removed automatically. So we have environment only when we really need it. If any test fails, the environment will remain and the engineer will investigate the root cause of the issue. And the last step, here we get test result, convert them to human-friendly format, and send over email to all team members. Usually, build starts automatically on schedule, but there is an option to queue build manually as well. So now let me show you what is really happening on deploy environment step and what ARM templates we use to deploy the environment. Here, my repository. So we have 4 projects in repository. The first project is a cleanup project that will remove all the resources. Number 3 contains all the test automation. Number 4 is a project that verifies test results and sends test report over email. And number 2 is our primary deployment automation project that contains all the ARM templates. There are Active Directory, SCOM, virtual machines with SQL and server product templates. We have also virtual network gateway template. And on top of these templates, we have a PowerShell script wrapper that orchestrates the deployment. Deployment itself consists of several steps. First of all, we deploy entities that we could not deploy in parallel, like a resource group, a virtual network gateway, a virtual machine with an Active Directory. Here we have ARM template that deploys Active Directory virtual machine. There are a number of resources that we deploy inside this template. First is a storage account for virtual machine. The second one is network interface. Next, we deploy virtual machine itself that depends on network interface and storage. After all, we use this Azure ARM extension and simple PowerShell script right here that install an Active Directory on the virtual machine. Because we need a secure connection to our environment, we also configure virtual network gateway with this ARM template. There are few resources in this template that we deploy. So first one is virtual network. Next is public IP, and then virtual network gateway. So after all prerequisites deployed, I mean Active Directory virtual machine, resource group, and network gateway, on the second step we deploy multiple virtual machines in parallel. The beauty of Azure that it can deploy as many virtual machines in parallel as you want in a predictable time. We deploy System Center Operations Manager machine and all the virtual machines with different SQL versions and versions of a server product and all the prerequisites. As a very final step, when all these virtual machines deployed, we use a number of helpers to deploy SCOM server, server product configuration, and at the very final moment we deploy SCOM agent to all virtual machines. Now when all environment is up and running, test execution starts. As I said earlier, it's not the only one way how we could use these ARM templates. Any team member can deploy this environment with a single script run. So here I have a Cloud Shell, and I have the same deployment script uploaded. If I run this script, it will, without any parameters, it will deploy the minimal possible configurations that we use for development. If I need more complex environment, I need to specify some parameters, and it will do complex deployment. We will not wait while this script completed. Let me show you a really quick sample of simple environment deployment. So here we have Active Directory virtual machine, we have agent virtual machine, and we have SCOM itself. So this is a minimal configuration that we use for development. It takes only a few seconds to run a script and about 30 minutes to deploy such a simple environment. And compare this to 2 or 3 hours of continuous manual work to deploy the same environment. And it's really awesome. It's really fast. Now let me back to presentation. So here you can see test results emails that we receive after all tests passed. Here we could see total test count and details of the execution. So this is the final result of all this solution. During development, we faced with a number of issues, and I want to share the most interesting pitfalls with you. So number one, it's not enough of recourse on the location. As you know, there is a limitation on cores on the Azure location. As a workaround, we catch such errors in our scripts and change the location automatically. Number two, that we faced, with increasing number of tests and deployment platforms, we've started to approach VSTS agent run duration limitation. Fortunately, now this limitation is gone. A few weeks ago, Microsoft removed this limitation, and you can run your deployment and test automation as long as you need it. There is no run duration restriction anymore. Now, let me summarize what benefits we got with this ARM template-based deployment automation. We've significantly improved reliability and eliminated manual operations. Significantly improved time to deploy. Now it takes about 2 hours of duration to deploy the environment, the big environment, and only 10 minutes of work. Compare this to 40 hours of continuous manual work when you deploy the same environment manually or with somewhat semi-automation. As a result, our release cycle decreases from 60 to 16 hours. Now our solution is really scalable, and we can deploy as many environments as we need. And it's really cost effective because we keep environment only when we work with them or run test automation. Finally, with ARM templates and implemented infrastructure as a code practice, now if management pack works on dev environment, it will work on test environment, because all environments are equal. Alexei, that's all I wanted to share about infrastructure deployment automation on Azure, and now it's time to share the second case study.
Thank you, Alex, for interesting case study. Now let's examine past case study. Before jumping to the demonstration, I'd like to briefly overview the project and project's goals. Our customer owns a line of business reporting web application used by their employees internally as well as by partners externally. The application consists of the following components, as you can see on the slide: Azure App Service, which is web app front-end part, Azure SQL Database, which is backend database for the application, and Azure Analysis Services, to generate business reports on the fly. So this PaaS application deployed through ARM templates and PowerShell scripts. As one of the steps of the project, customer wanted to implement native to Azure monitoring solution based on Azure Application Insights for web app monitoring, Azure Log Analytics for Azure SQL database monitoring, and Azure Monitor for analysis services monitoring, Azure Analysis Services monitoring. Also, as part of the monitoring solution, customer wanted to implement Azure Portal for dashboards and Azure Alerts for notification. The application deployment, configuration, and management provided by special dedicated team. And our part in the project to configure PaaS application monitoring without any disruption of the application and package the configured monitoring environment into separate ARM template. So our goals related to ARM: no manual deployments, only automated packaged deployment of the monitoring environment, and also it should be extensible monitoring environment. Check into version control and follow the infrastructure as code practice. Our customer uses Visual Studio Team services and its release pipeline. Also, third goal, continuous monitoring alongside with continuous deployment of PaaS application. The idea behind the third goal, the PaaS application deployment and monitoring should be through ARM templates. On this diagram, you can see partial example related to Azure SQL database monitoring environment only for our customer. Let's review it. First of all, we use master template, Azure SQL monitoring template, and corresponding parameters file. Master template used as a parameter holder and as a deployment starter for the nested templates. Nested templates consist of two top templates. You can see it on the top, Azure SQL Diagnostic Settings template and Action Group template. The Azure SQL Diagnostic Settings template enables logs and metrics from Azure Monitor to send them from the particular Azure SQL database to the Azure Log Analytics workspace. Action Group template creates and configures the action group with the list of emails of the management team on the project. Other two nested templates, Azure SQL Dashboard and Azure SQL Solution and Alerts. Azure SQL Dashboard template depends on Diagnostic Settings template and creates the Azure Portal Dashboard based on Azure Log Analytics, Custo, queries, and tiles. And finally, Azure SQL Solution and Alerts template depends on both top nested templates and deploys the Azure SQL Analytics Management Solution for Log Analytics, creates Custo saved searches and alert rules. By the way, these rules based on the new type of the alert rules in Azure. On the current state, the template file is executed through PowerShell, but on the next project sprint, it will be implemented as part of CI/CD. Now, maybe you wonder why so many nested templates. There are some reasons, and I want to show two reasons. The obvious reason is related to deploying resources to more than one resource groups. For example, Azure SQL database sits on one resource group, whereas the Log Analytics workspace, action groups, and portal dashboards reside in another resource groups. Totally 5 resource groups. Another reason is to make dependency on diagnostic settings configuration. Okay, now demo time. Let's see my environment, Azure environment. I will use Azure Cloud Shell as in previous demonstration. Let me reconnect it. While it's reconnecting, let me show the database and Log Analytics workspace to understand the context. I'm using DemoDB. This DB created for this example. If we will go to the monitoring blade, we can see here the diagnostic settings section. If we'll click, as you can see, there is no diagnostic settings here, and we will create it programmatically through ARM template. Also, if we will go to Azure Log Analytics workspace, we have this particular Log Analytics workspace, DB Management WS. Let's open it. And if we'll go to General tab and see the Alerts blade, Alerts, we can see that there are no alerts here because they are not created. And we will, of course, we will create them through a template. Now let's briefly review the template and parameter file. Cloud Shell already opened. Let's clear this. I'm opening editor, which is inline editor in Cloud Shell. There are three files. Azure deploy.json. It's some kind of default naming convention for templates. You can use what you want, but it is good to use Azure deploy.json for master template, and you can name your internal nested templates as you wish. Anyway, it's choice of the user. We can see here the blocks discussed earlier in the introduction section. There are 6 blocks, parameters. For example, we need DB name, DB server to create the database ID, the diagnostic settings name, and also Log Analytics workspace name. Also, we have variables to use it few times in the template body, and we have here resources. For nested resources, sorry, I need to close it, close editor and open it again. For nested resources, we use Microsoft.resources/deployments resource type, and inside this resource type, we declare our resources as nested resources. In this case, you can see this is diagnostic settings resource for particular database name. We know this database, DemoDB. Another file, Azure deploy.parameters.json. It is corresponding parameters file. In this file, we can see only 3 blocks: schema, content version, and parameters, filled by values. And this file will be used in this deployment example. You can define parameters here, or you can define in, for example, PowerShell script as inline parameters, or for example as inline hash table of parameters. And here's deployment.ps1. It's simple deployment script. What we do here, we define variables, for example, name of the resource, target resource group, which will host the deployment itself, the name of the deployment, it will be named master deployment, the path to the files of template itself and parameter file, and the command let to run the deployment. As you can see, to execute deployment through PowerShell, you need to run new Azure RM resource group deployment command let. You need to define the name of the deployment, resource group name, template file, and template file parameters. Template parameters file, I'm sorry. And one interesting thing is mode. We use in our project incremental mode, which means that everything which existed in targeted resource group will not be touched during the deployment. And there is another mode, is complete mode, which means that after deployment in the targeted resource group will be only resources declared in the template. Why we use incremental? Because, as I mentioned earlier, our customers management team, for application management team, they run their deployment on the same resource groups. That's why we need coexist in separate deployments of monitoring environment and of the application deployment and configuration itself. That's why we use incremental to avoid any disruptions. So let's execute this template and see how it's fast and useful for us. Let's do this. We need to run this template. As you see, there are a few steps in deployment. One of the steps is validation of the template, creation of the deployment on the target resource group level, and running actual deployment based on the declared resources in the file and the dependencies between resources. So the dependencies, again, they manage the order in the deployment. If you do not define the dependencies, the ARM will decide by itself how to deploy these resources in parallel, if it's possible. So this deployment is very, very fast. I'm using verbose parameter in the PowerShell commandlet to see every step in the deployment. And as you can see, as a result, we have some summary. The name of the deployment, resource group, provisioning state, in our case succeeded, timestamp, mode, parameters, values, and names which use it in this case, and outputs if they are defined. You can review this information through, for example, PowerShell commandlets or on the portal, and we will see it in a minute. Let's review how things deployed, how resources deployed. Again, we're back to our DemoDB database and to the diagnostic settings tab. Let's refresh it. And as you can see, we have this particular database has the configuration of diagnostic settings, and the diagnostic settings, among them metrics and logs, they are streamed to the particular log analytics workspace. Also, if we will back to our log analytics workspace, in the general section alerts blade, we can refresh, and as you see, we have 5 alert rules created through ARM template. And another one thing I want to show you, deployment history. Our deployment targeted at management RG to this resource group. It is central management resource group used for deployment and for log analytics workspace residing. And if we will go to settings blade and we'll check deployments, as you can see, we have this master deployment and its status and other information. And as you can see, the total time of deployment is 48 seconds. If we click here, we can see the nested templates, as you can see here, their deployments. We can see outputs if they define it, inputs of the template if they define it, and the template itself. And by the way, it's a great method of creation of the template. Let me back to the presentation. During the ARM template development on the current project, we met few problems, and one of them I'd like to share with you. The problem, diagnostic settings resource type, is nested resource type. It is not a problem itself, because you can define this diagnostic settings resource type as a nested resource type in the parent resource definition in the parent template, and Microsoft recommends to do it. But in our case, as I mentioned, the application deployment managed by another team, and we didn't have an opportunity to extend their template with their resources, parent resources. So just imagine how to create this particular resource for Azure SQL database in different template. So the resolution of the problem or the pitfall to correctly define the resource type and name. As you can see here, we defined resource type as a Microsoft.SQL namespace /servers/database. It's parent resource type for Azure SQL database, and then concatenate with diagnostic settings resource type, provider/diagnostic settings, and resource name for the SQL database, full name with server inside it, and the Microsoft.Insights resource provider for the diagnostic settings. By the way, Microsoft.Insights, this namespace used for Azure Monitor resources. So now then ARM runs the deployment with the correct resource type and resource name. It will construct the diagnostic settings resource ID correctly without parent resource. I hope it was helpful to you. So what we have achieved using ARM templates on this project: automatic configuration of Azure SQL database monitor environment, as well as other components of our application, Azure analysis services and other resources. Reproducible deployments. We can run it right now on production, staging, and test environments to check what we need. Also, it is perspective for CI/CD implementation as our customer required. And one great thing here, decreasing time to deploy from manual 16 hours of configuration to 1 minute or less. That's about it. Let's summarize our presentation. If you manage Azure resources, deploy them, clone, or do other operations, don't miss the excavator. Why? Because ARM and its templates are good for declarative, simplified, managed automation, decreasing time to deploy and release, complex deployments as you saw with extensions and dependencies, and they are good for infrastructure as code practice. Before we move on to the Q&A part of our webinar, I'd like to take a moment to remind you about what Akkad does. Akkad is a DevOps consulting and software development company. We are ultimately focused on the cloud DevOps and Azure migration services. By leveraging the most advanced practices and newest Azure management services, we help our customers build a modern, automated, cloud-based and client-driven release pipeline. Besides that, our traditional focus on IT outsourcing and developing custom monitoring solution for the applications, hardware, and appliances with System-Centric Operations Manager and Azure Management Services. Please send your questions to devops@viacode.com email and visit our website azure.do. By the way, DO stands for DevOps. Let's see what questions we have. Okay, we have a few questions here. Let me answer. Jeff asks how to run ARM template deployment on Linux. It's pretty easy. You can run using Azure CLI v2 cross-platform utility, or you can run Azure Cloud Shell as we ran in demonstrations. And by the way, there is an option to create not PowerShell but Bash-based Cloud Shell, and this cross-platform Azure CLI is available there. Also, you can use Ansible third-party configuration management tool or Terraform, for example. Regarding first demo, you said you were able to accelerate the environment deployment up to 20 times. I would like to know if that is a limit or if there is an opportunity to speed the deployment up more. Let's review the answer from Sergey. There are several ways to speed up the deploying even more. In our backlog, there are issues for this. For example, to deploy complex systems, we would like to try using containers, or to deploy identical elements of the laboratory, we can apply the parallelization of tasks even more than we have now. So the base idea behind this answer is containers and parallelization. So this is the answer. So okay, that's all for questions today. If we will find any other outstanding questions, we'll share the questions and answers after this webinar. Right now, let me say thank you all for joining us today for this Automate Infrastructure Deployment with Azure Resource Manager webinar. Alex and Sergey and I were very grateful to you. As I mentioned before, slides and recording will be available after the webinar. So stay tuned, following our Twitter account or by visiting wirecode.com website. And thank you so much for your attention.